Hello and welcome to lesson 6.2. Today we will be studying multiplying and dividing rational expressions. So I've got a couple things set up. First we're going to try multiplying. Now multiplying is simple. You can go straight across the top and straight across the bottom. So there's two ways to do this. Write it as 20 over 8 times 15, and of course you're dealing with numbers that are a little more difficult to do in your head. 20 over 120. And then you can reduce this fraction by dividing each of these by 20, and you get 1 over 6. Now that way kind of requires a calculator or really good mental math. There's an easier way, and that's if we simplify first and then multiply afterwards, because the 5 and the 8 won't simplify with each other, but the 5 will simplify with the 15. 5 is 1/3 of 15, and then the 4 and the 8 will simplify with each other, and 4 is 1/2 of 8. And of course now on the numerator we have 1 times 1 is 1, and in the denominator 2 times 3 is 6, and we get the same answer, and we don't have to worry about multiplying big numbers or about reducing the fraction at the end. A lot quicker, a lot simpler. You don't need a calculator and you can do it all in your head. Variables work in much the same way. Here we have two x's in the numerator. One of these will cancel with this one, and the other one will cancel with this one. Here we have two y's in the numerator. One of them will cancel with this one, and that's it for y's. And then your 4 and your 8, 4 is 1/2 of 8. So all we're left with in the numerator is a 1 times y, which is just y, and in the denominator we have a 3 times a 2, which is just 6, y over 6. Now we get into some more complicated ones. Just like the advice I've given you in some other areas, we're just going to factor and factor until we can't factor anymore. So factor everything. Every numerator, every denominator, bust it into as many pieces as you can, and that will make things much simpler, because I don't want to multiply a trinomial by a trinomial here and then have to divide it by the product of two binomials. That's a nightmare. So let's take a look at our numerator. A squared minus a minus 12. You can use your sum and product here. Two numbers that multiply to give you negative 12 and add up to negative 1 would be minus 4 and positive 3. So a minus 4 times a plus 3. This here is a difference of squares. We've seen a lot of these. So that is a plus 3 times a minus 3. This numerator, again, use your sum and product. Two numbers that multiply to give you positive 3 but add up to negative 4. So that will be a minus 3 and a minus 1. And then your denominator, all you can do is take out a common factor of a, and you're left with a minus 4. Now it doesn't look a whole lot simpler, but if we look closer we'll find out there's some simplifications we can make. A minus 3 will cancel with a minus 3. The factors have to be identical in the numerator and denominator in order for you to cancel them off. But if they are, they just completely disappear and leave you with 1, which obviously doesn't change anything when you multiply. So the a plus 3's will cancel off. We have an a minus 4 over here and an a minus 4 here. And all we're left with then is an a minus 1 on top and an a on the bottom. And this is as simple as it can get. We can't divide the a by the a, because the negative 1 is also divided by the a. So if we wanted to do that, we would have to rewrite it as 1 minus 1 over a, and really, is this any better than this? Not really, so we might as well just leave it in our original form. Alright, dividing rationals. There is an alternate method in the textbook. If you want to explore it, feel free to go ahead and take a look. It involves finding a common denominator and then just dividing. I find this way easier and foolproof. but if you have questions about the other method or you prefer to use it, then we'll use it. So here's a simple example of multiplying by the reciprocal to divide. 5 divided by 1/2. If you plug this into your calculator, 5 divided by 0.5, so that's 5 divided by 1/2, it will give you 10. And why? Well, we multiply by the reciprocal. So instead of 1/2, instead of dividing by 1/2, we multiply by 2 over 1, and then 5 times 2 will give you 10, and obviously the 1 on the denominator doesn't change anything. So let's take a look at this more complicated example. Again, same advice. Factor everything. I'm not going to write it out again because it's time consuming and useless. So let's take a look at this one. This is a difference of squares, x squared minus 4, both perfect squares, so x minus 2 times x plus 2 in the numerator. Denominator, we can factor out common x, and we're left with x minus 4. Instead of dividing, we are going to multiply by the reciprocal, so we just take the entire thing and we trade places with this entire thing. So now in the numerator we have x squared plus x minus 20, so two factors that multiply to give you minus 20 and add up to positive 1 would be x plus 5 and x minus 4. So that now becomes the numerator. Denominator, two factors that multiply to minus 6. So these are all the possibilities, negative 3 and 2, and negative 2 and 3. And we of course want to choose the ones that add up to positive 1. So that's negative 1, that's 5, that's negative 5. So it's this one here, positive 1. So we have x minus 2 and x plus 3. And now we can worry about carrying out the multiplication and see if there's anything we can cancel. X minus 2, gone. X minus 4 and x minus 4 also gone. So we can simplify here. In the numerator we have x plus 2 times x plus 5, and in the denominator we have x times x plus 3. And if you wanted to FOIL out your numerator and distribute your denominator, your final answer would look like x squared plus 7x plus 10 divided by x squared plus 3x. These are the same thing. I will accept either answer. I tend to like them broken down, so I wouldn't even bother taking the time to do this because it's not any more meaningful than the fully factored form for me. Okay, sometimes we might have to do both multiplying and dividing in the same problem. Do it in order from left to right, so if you find you have to divide by this, flip it and multiply, and then do this multiplication last. So let's start by factoring our numerator here, and this will be 2m and m in this set of brackets, two numbers that multiply to give you negative 15, but when multiplied by 2 will add up to negative 7. So m minus 5 and m plus 3. And you find 2m times minus 5 is minus 10m, plus 3m will give us the required negative 7m. In the middle there, and the denominator, just take out a greatest common factor of 2m, and you're left with m minus 5 there. Now we're going to flip this and multiply, so we get 6 on top, and in the denominator this is a difference of squares, so 2m minus 3 times 2m plus 3. And then we're going to multiply this by 3 minus 2m, very last. See what we can do for canceling here. 2m plus 3 is here and here, so those will disappear. M minus 5 here and here, those will disappear. 6 divided by 2 will leave us with 3 in the numerator. This m is still here, don't forget about it. Here, 3 minus 2m is the opposite of 2m minus 3. If we take out a negative, then we can flip the sign on both of these, and now we have 2m minus 3. And if we leave the negative 1 here, this can cancel off. And all we're left with then, in the numerator, we have negative 1 times 3, which is negative 3. And in the denominator, all we have left is m. And that is our answer. So we went from something really complicated to something that ended up being really simple because of all these factors that we had in common that we were able to just strike off and they completely disappear. That's it for today. I'll see you in class tomorrow. We need to spend a lot of time getting some work done today and practicing 6.1 and 6.2 for the quiz on Wednesday. So watch the video quickly and come back to me with questions and ready to work and get things done. Okay, see you later.